Today we are going to look at trig forms of vectors. Okay, so we've had the component form, we've had the linear combination form, and now we're going to look at trig form, which is a variation of the component form. And I'll explain that a little bit better when we get there. All right. So the first thing we're going to look at is the trigonometric forms of a unit vector. So a unit vector has a length of 1, considering it's a unit vector. So it says here, let's see. If u is a unit vector, then the terminal point of u lies on the unit circle, because the vector acts as the radius, right? So if this is, here's vector u, there's 1 unit there. And the terminal point then is at AB. But remember, on your unit circle, your ordered pairs are all cosine theta, sine theta. Okay. So this u that we could call AB in component form can be written as vector u is cosine theta, bless you, sine theta. Okay. Or, as a linear combination, could be cosine theta I hat plus sine theta j hat. Okay. All right, so now to look at trigonometric forms of any vector, not just a unit vector, it says because every vector v is the product of its magnitude, okay, and its corresponding unit vector, u. We can write v in the following forms. So we could say, so if I have vector v is equal to the magnitude times the unit vector. Okay? That means that it's the magnitude of v times, we just defined the unit vector as cosine theta, sine theta. Then from what we know about the scalar multiplication, the magnitude is just our scalar, so we can multiply it by both components in there and get the magnitude of v times cosine theta, comma, magnitude of v times sine theta. Or we could also write it as a linear combination and say that v is equal to magnitude of v times cosine theta I hat plus magnitude of v times sine theta j hat. Okay, we good so far? All right, so now we are going to, it says find the component form, and the component form is the pointy bracket form of each vector. We're given the magnitude and we're given the direction angle. So if I'm given that, and I know, so I have the magnitude and the angle, I can just put it into this to get my vector. So vector v would be equal to the magnitude, which is 8, times the cosine of 60, and then 8 times the sine of 60. And we don't need the calculator for this because 60, what's 60 in radians? Pi thirds, right? So pi thirds, so I can say my vector v is equal to, all right, so what's the cosine of pi thirds? 1/2, and 1/2 times 8 is 4. What's the cosine of, what's the sine of 60, or pi thirds? Square root of 3 over 2 times 8 is going to give me 4 square roots of 3. Okay? Easy enough? All right. We're going to do number 2. So I have vector A here. So vector A is equal to 30 times the cosine of 340 and 30 times the sine of 340. This one we're going to have to do on the calculator. Go ahead and type those in. So you should get 28.191 for the x component. Do we agree with that? And then you get negative 10.261 for the y component. This vector is pointing towards which quadrant? Fourth. And this is 340 degrees. So does it make sense that it's the fourth quadrant? Should make sense. Okay, good. So these forms right here, this is the trig form. Okay? Trig form literally has trig in it. But it looks like component form because it has the pointy brackets, but component form is just numbers. They could be exact values, but they're not going to have the trig words in them. This is your component form. Because remember, you have to know the words and what it's asking you to do so you can answer the questions correctly. We had to put it in trig form to get it to component form on this part. We good with that? Awesome. All right, so back here it says write each vector in trigonometric form. All right, so in order for me to write it in trigonometric form, I have to know the magnitude and I have to know theta. They've given me component form. So I have to use my component form to find those things, which is what we did on that first day. So if I want the magnitude of m, remember what we do? The square root, it's like it comes from the Pythagorean theorem, right? So it's the square root of negative 3 square roots of 2 squared plus negative square root of 6 squared. Sometimes things like this, it's safer to do by hand than on the calculator, because if you type something in on the calculator, you're going to assume whatever it gives you is right, because it's calculated, right? But you got to be careful how you type that in. So everybody type that in, and let's make sure we can all get the right answer. You should have the skills to do it by hand also, but calculator's fine as long as you can use it correctly. You should get 2 square roots of 6. If you didn't, you missed parentheses or something somewhere, and that's why it's sometimes better to do by hand. Calculator's only as smart as the person pushing the buttons. Right? You're only as strong as your weakest link. All right, we good? We all got that? It's the square root of 6. Yeah. Okay, so there's my magnitude. Then I need to find theta. Theta is equal to the tangent inverse of negative square root of 6 over negative 3 square root of 2. So remember, what the calculator is going to give you is alpha. So let's find alpha. What do you get for alpha? It's 30, because this would just reduce to square root of 3. I'm sorry, square root of 3 over 3. All right, so then I have to ask myself, all right, so what quadrant am I trying to use here? The third. This puts me in quadrant 3. So to get to quadrant 3, what do I do with this 30? Add 180, so that gives me 210 degrees. Okay. So now I have my magnitude and my direction angle. Everybody with me so far? Okay, so now the vector m in trigonometric form is going to look like this. 2 square roots of 6 times the cosine of 210, and then 2 square roots of 6 times the sine of 210. That is trigonometric form. You don't do anything else with that. Because guess what? If you type this in, this is what you're going to get back. And you're just going in circles. Okay? Now, your assignment today is on, we're not finished, but it's on a worksheet and informative. So informative, I will already have this first part with the equal sign typed in, so you have to type in the rest, which means you have to type in the pointy brackets. Just use the pointy brackets that are on your keyboard. You don't have to go to a fancy menu or anything like that. If you have fractions in there, though, it makes these look little tiny and wrong. Don't worry about it. It was like the only way I could figure out how you could type it in anyway. So, and don't put the degree signs on here. The only place you should have a space is where you'd naturally have a space there. Okay, it should be fairly simple to type in. All right, any questions? Okay, so let's look at number 4. What form is this? Linear combination. So this is a linear combination. In order for me to get magnitude and stuff, I need it in component form. So that's really easy to fix. That's just -2, 2, right? So then I need the magnitude of r. That's equal to the square root of -2 squared plus 2 squared. And I'm not having you type stuff like this into the formative because I feel like it would be a nightmare. But on the quizzes and tests, I expect to see the correct notation. So don't get sloppy in your work just because you're not typing it in. Make sense? All right, so what do you get for the magnitude of r? Is what? 2 squared to 2? 2 squared to 2. All right, so then theta is tangent inverse of 2 over -2. I feel like I don't need the calculator for that either because doesn't that just reduce to -1? Okay, so then I want to use the positive one to get alpha. So when is tangent 1? Pi fourths, okay? And pi fourths should probably be the first thing that pops in your head. But then we don't want it as pi fourths, so then we get into what? What's pi fourths in degrees? 45. I mean, you can use the calculator, but things we know too. All right, so then what quadrant are we concerned with here? Second. So in the second quadrant, what do I do with alpha? Subtract from 180, so that gives me 135 degrees. So I have my two pieces there, and then I can say that vector r in trigonometric form is 2 square roots of 2 times the cosine of 135, 2 square roots of 2 times the sine of 135. Any questions at all? All right. So on number 5, they've given us the initial and terminal points. So we need component form to be able to do that. Now, mine was missing for some reason, and yours isn't. So I don't know how the heck it disappeared off of mine, but that's why it's written funny. So vector yz then in component form. Remember how to find that? What do? Subtract. Very good. So 5 minus 3 gives me 2. -8 minus -2 gives me -6. So you go ahead and do this one. Find the magnitude, find the angle, put it in trigonometric form. Okay. Double check yourself with me. Let me know if you have any questions at all. Right, don't use the negative, just that way you get alpha. There is a way to take care of it, like use it as the negative and think about where it is, but then you have to think about every single one of them differently. So if you're just consistent and always find alpha, then it just makes everything easier. Anything else? Good questions. Alrighty, so get to work. Remember your stuff is informative and on the paper that I gave you.